Abhinav Shah, electronics engineer. He started his career in plastics industry in 2013. He has gained experience with various facets of the business, namely servicing, designs, and customer support. He has undergone training at various overseas companies in Europe during his present tenure with Madhu Machines and Systems Private Limited. Ladies and gentlemen, we have with us Customer Technical Support, Madhu Machines and Systems Private Limited. Please get your hands together for Abhinav Shah.
To one and all present at the summit. I would firstly like to wish TAGMA for their success over the tooling summit and the contribution to the tooling fraternity. Over the past 27 years, Madhu has been pioneer to bring in innovative technical solutions to Indian plastic process and tooling solutions. It has been now more than 23 years that Madhu has had successful collaboration with Kumsa for bringing in contemporary tooling solutions. I would now request to play a video on Kumsa. Can we have the video, please?
Kumsa, founded in 1974, as a small family company dedicated to the design and production of molds. Throughout the early years and our growing experience, we could see that the customer's high-quality requirements could not be met due to technical difficulties typical within this sector. So we began creating our own solutions to these problems, developing parts that drastically improve the performance of our molds. Upon realizing just how much of a revolution our parts were, we discovered our future: innovation. At Kumsa, research and development is the motor of the company, and innovation, our DNA. We design and produce completely interchangeable standard parts for mold makers and molders, which allow reduced mold manufacturing time between 30 to 40%. Simple installation and adjustment within the mold. Fast replacements from the parting line. Minimized production downtimes. Reduced mold sizes. And cheaper production costs. Years of hard work, determination, and precision have made us a leader of standard parts within the molding industry. Our constant growth wouldn't be possible without the direct contact and feedback from our end customers, a goal we achieve through DTM Kumsa, who continue our original idea of the production of molds. Our best guarantee: 40 years of experience, and our branches in Portugal, Italy, Germany, China, and the USA. We were born reinventing, and we continue innovating. Kumsa, we are innovation.
Thank you. As rightly said in the video, that the innovation is in our DNA. So we straight away jump into our topic: futuristic technologies to overcome the challenges of undercuts, air entrapments, and ejections in plastic tooling molds. I will start with an example of a simple small size undercut. The conventional way to release the same is by using an angular device, whereas in Kumsa we use sprung core, which is very compact in design. Here's a small animation showing the sprung core working. All the machining is 90 degrees from the parting line. That's the biggest advantage. Here's this image showing an undercut on the two sides, which is released by two face-to-face sprung core. And as we all know, since 1990s, the sprung cores are widely used. So as a part of an innovation, we have in place of sprung core the new smart worm pin concept, which is structured using a traction spring and steel cable, thereby improving flexibility, strength, and longevity. Here's an animation showing the working of a smart worm pin lifter. The ejection strokes start from 60 mm to 120 mm, demolding the undercuts up to 13 mm. Here's a technical analysis of various products having different kinds of undercuts and wherein the worm pin lifters have been used to release them. Now, the biggest challenge for undercuts, those are dog housings. What we have here is on the left side, we can see a simpler system of Kumza, whereas on the right is the conventional system, wherein two angular pins are used and which requires a precise 3-axis and 5-axis machining. Here I would like to take you through an animation showing a difference between the traditional solutions and the new double rack system. This is the typical double, that's the innovation from Kumza, the new double rack. This system eliminates the need of high precise angular machining. That's where we can see the difference. The conventional system have largely more ejection strokes because of its angular function. And with Kumza double rack, we can demold undercuts with a draft of -55 degree to +35 degrees with a maximum ejection stroke of 125 mm. Now that's a big saving. Here's an image showing the construction of double rack lifter assembled into a tool with a plastic component having 3 different draft angles, one with negative, positive, and another at flat. So all the 3 different undercuts are released with the same ejection stroke. That's a profitability study between a conventional system and a Kumza system with the same part. This is where we see the advantage, that the mold height is reduced almost by 150 mm using Kumza system. That's the image of the part having the dog housings. This is one of the most complicated case study of a door trim having different dog housings undercut right from 0 degree to -10 degrees. That image shows the placement of double rack lifters with the dog housings into the part. The image on the left shows a cluster of undercuts are released with a common insert using 2 double rack lifters. This is a picture, actual picture of a tool of a door trim installed with double rack lifters. Here's a very interesting profitability study made by C-Molds between a conventional lifter and the new double rack system. We can see the typical construction on the left of the angular lifters, and on the right we see the Kumza systems installed to the part. What we can see on the right, that we are getting bigger space to accommodate the ejector pins at the right places and also to achieve the symmetry of the cooling. This is the difference of machining between the Kumza system on the right, and on the left we have the conventional system. This is the ejector plate. So overall, using the Kumza system over the conventional lifter, C-Mold saved around 6,000 euros as a saving. Here we have another case study between Group and Tolin. Group and Tolin saved 76% of less working hours with Kumza system and 44% of less ejection stroke. Now that I would say is a big saving because you're reducing on the tool height, that in turn reduces the cost of the steel. The image on the left shows how complicated it was to release the undercut using the sliders, whereas on the image on the right shows double rack systems installed vertically and enabling to reduce the tool size. Also, what we can observe, that the cooling is taken right to the insert, enabling cooling the part what is required to be cooled. Now that's an animation showing double rack system with cooling system. That's in another case where we have taken the cooling right to the insert. Here's a case study between conventional cooling system and an Kumsa internal cooling system. With Kumsa internal cooling system, customers able to achieve 70 mm of less ejection stroke. Now, one of the biggest challenges that we all face is the air entrapment in the mold. I would like to take you through a brief animation which itself would speak. That's the air getting trapped into the mold. The air gets cornered at one end, at the last fill area, and we observe burn marks or non-uniform homogenization. Now, while installing a Kumsa system, what we do is that we drill the vacuum channels using the gas vent inserts, which does both the function. One is to take out or exhale the air from the cavity, and second, blow off the gas. That's the installation of the vacuum jet system. And the complete tool is sealed to achieve the hermetic tool. So what happens? When the mold closes, the signal is given through the solenoid valve to the vacuum jet system, and before injection, all the air is exhaled from the cavity. That's how the air is being taken out. And the same goes on even during the injection. Because more often than not, while using engineering plastic, it tends to produce gases during injection. And also, after the injection process is completed, the blowing process starts to take place, enabling to achieve easy ejection of the part. Here's a case study showing an image with and without vacuum jet system. The image on the left, we can see a short fill area. But after installing the vacuum jet system onto a runner, customer was able to achieve a 100% filled part. That's in another case study showing the unfilled ribs, because it's obvious the air gets trapped at the end. But what we have here is that we have placed one vacuum jet valve at one corner of the cavity, and it exhales all the air from the cavity, which enables the component to fill completely. Hence, we can see all the ribs are evenly filled. Here's another case study where the raw material is polyamide with 50% glass fill. And what we can see here is the burn mark or the short fill. But after installing vacuum jet system, we are able to achieve a 100% good quality part. Also widely used in transparent components to have clear aesthetics. That's an interesting case study of a chair, the stand. The image on the left shows a lot of air bubbles within the component, disallowing the melt to get homogeneously mixed. Whereas the image on the right shows a nicely bonded plastic, allowing it to withstand the weight up to 1,600 kg. Now, we move to the last part of our presentation, that is ejection. This is the most simplest and the most common mechanism which we have in our product portfolio. For the two-stage ejection. The installation is very easy with this. That's the double ejector. This unit divides the ejection unit and the travel into two predefined strokes. So at the first stage, we release the undercut, and at the second stage, the part can be ejected. This unit can be placed diagonally into the ejector plate and also acts as a guide pillar. Madhu Group. It's been 27 years of innovation now. In 1984, marked the year when our chairman, Mr. Madhu, started the company Madhu Marketing as a consultancy firm. 1995 saw the introduction of massive hot runner systems. Thus began a journey of widespread commercialization of hot runner usage in Indian plastic space. Till date, Madhu's pioneering effort are acknowledged as the key contribution to the growth of this fraternity. In 1996, bringing yet another futuristic technology to Indian shore in form of Kumza innovative components. In the year 2009, giving back to the industry was always in foresight of Madhu. The first Tagma aggregated testing facility was set up in Bangalore in the year 2009. 2010 onwards, Madhu pioneered several 2K projects done for the first time in the country, including the hugely successful massive system supplied for 32+32 cavity 4-phase cube mold, the first of its kind manufactured in India. In past 2 years, our machinery division has supplied several additional injection units. To summarize, we thank the industry for having given us the opportunity to execute over 3,000 projects with more than 400 customers across the Indian subcontinent, Middle East, and Africa. Thank you very much for your kind attention.
Thank you very much, Abhinav. Ladies and gentlemen, may I request Mr. Paresh Panchal to please step up on stage and hand over a memento to Mr. Abhinav Shah, Customer Technical Support, Madhu Machines and Systems Private Limited. Can we once again have a huge round of applause, ladies and gentlemen, for Mr. Madhu Shah, for Mr. Abhinav Shah.